Hey guys,
Hey, Jim.
Okay, good morning.
let's give one more minute for others to join and then I'll start. Okay, let's start. Can everybody see my screen?
Yes, I can.
Okay, great. So I have I have some slightly potentially bad news in that I think perhaps the recording from our last meeting might have been removed from the Zoom menu. I got an email from Zoom saying, yeah, here's your meeting. It's available at this link. And I think I might have actually clicked on it and listened to just a few minutes. So in preparation for today's meeting, unfortunately, I had not posted or copied that information to our OCP drive. And when I went to click on the link from the email um, from Zoom, it said, "Sorry, this recording is not available." And I was under the impression that Zoom would keep that for some number of months. And in fact, it hasn't even been 30 days. But I need to run down that. But right now, I don't have a recording from the last meeting. So um, perhaps we might wind up having to re-go over some of that information. Um, Today, what I wanted to do is I wanted to talk about a topic I'm calling enhanced event reporting. I've got a slide deck to show you. About half of it is cribbed from the OCP talk um, that was presented a couple of months ago. But it's responding to some of the comments I've heard um, lately um, where our semantics don't fit some of the use cases that a data center operator would want to have available in his tool set. Um, and it happened to coincide with a particular area of issues that my company deals with. So it was actually um, quite interesting for me to go through and look at this and say, well, what's this abstract new capability that we're talking about adding, and how might my company leverage it for an issue that we deal with? And you'll see that in the slide. All right, so let's go through here. So just an overview. We have SCIM telemetry semantics that we've been working on through most of 2025. I presented those at the summit. Additionally, behind the slides that were presented at the summit, we have this SysML model that we have various um, slides from that are on our shared drive. But if you look at that capability, there's two kinds of basic flows or two kinds of basic mechanisms that are included, and I've got a slide to summarize that'll show it, or a picture that'll seem familiar. One is sending a single instance of multiple meters in a highly regulated order, and sending infrequent uh, notifications of threshold crossing alerts. And let me just jump ahead to this slide. This is cribbed from the OCP Global Summit. But what we've been talking about is we set up this thing we call a stream. And then once the stream is set up, there is a regular occurrence of these messages, send metrics messages. And it could, at any given instance of time, there could be a send metrics message that at its regularly scheduled or regularly configured interval to report various metrics, um, and or there could be some event reported. And the only event we've really defined so far in this group has been threshold crossing alerts, or TCAs. And so let me just yeah. So one of the things as we refined this send metrics stream, we came up with an abstract way of looking at it, and we made some constraints for how they would be packed into a packet. And the purpose of this was so that the metrics in these sections could be visualized at a aggregation node, or perhaps a reporting node, as a bunch of arrays, with each element of the array, a given array, having the same size and definitions. And just to remind you, the reason we did that was so that at aggregation nodes, we could do row operations across arrays, the same row of multiple arrays coming from different leafs. And so we could aggregate across leafs things like the temperature, the power, the PCI errors, yada, yada, yada. There's another slide I don't have here, but was presented at OCP, about how you might also leverage that regularity of the metrics when you go fishing through relational databases. So I've heard comments here and there that say, well, how could we send a time series across? And there are people interested in time series. When I talk to people, I'm hearing that there's some data center operations or operators that find it useful to send a time series across, and certain protocols. I think Prometheus may be one. I'm pretty darn sure that OpenTelemetry is one that supports sending a time series. Um, so how do we do that? Because if we said we would support a time series, that just doesn't fit very well into here. And so one of the things that I was trying to do was to add this new capability that doesn't fit into our existing mechanisms. As I say back here on this overview slide, there's no mechanism to send a time series of one or more meters. Um, it's incompatible with the highly regulated ordering of multiple meters that we have defined today. And yet, diagnosis of some intermittent data center anomalies could be aided by conveying a time series of specific meters. And so the idea is that you have some event that doesn't happen very often. It's an anomaly, but there's some specific event of interest that's detected at the leaf node. And one of the things, and it could involve, so in reporting an event, we want to report more than just, hey, this bad thing happened. We'd like to present or include a variable amount of information. And then we might also want to include some metrics, some other metrics that we think may or may not be related, that happened before the event, and after the event. And so the mental model here, and I could have put this on the slide. I mean, for those of you who have done hardware design and used logic analyzers, you got something going on, or you want to see some event, and so you set this logic analyzer, sampling various signals, and then there's some trigger that you define, and when the trigger happens, the logic analyzer has some things that it remembers that happened before the trigger. It continues capturing some additional triggers up to some finite amount of memory, and then you get a picture. You can see the trigger, and you can see how things were before the trigger. You can see how things are after the trigger, and so that's the kind of the mental model in my mind. Um, like, but again, that kind of level or that flexibility in reporting doesn't fit well into our existing things that we've optimized for aggregation or for reporting. And so what I've specifically done here, and I want to explicitly say it, there's no attempt to aggregate this new enhanced reporting that you're going to see into the stuff that we're doing at an aggregation node. So, any questions on the overall goals before I plow forward with a real life example? Do I? And
So
hold on.
what is the
Oh, now
goal
I see
this?
hands. Sorry, I struggle with this all the time. Panos, you want to say something?
Yes. So first of all, to echo your analogy of using an analyzer on an oscilloscope that does pre-triggering. So it has this circular buffer, and as soon as you hit the trigger condition, it will dump the entire buffer that has past events as well, or past measurements. And that's like a common practice. I wanted to kind of correct one of your statements. The current implementation of Redfish telemetry, telemetric reports, does have time series as a concept.
Okay.
We may argue about the format, whether it's efficient or less efficient, but it has the concept of creating a report with time-stamped samples and sending you the entire report upon some condition. So if we were to do this thing like with a circular buffer or something, the oscilloscope analogy, I think this is already already fits what the Redfish telemetry reports support, and we could take that as a baseline.
Okay. Thank
Yeah.
you.
However, as you said, this would conflict with the concept of a continuous stream or an aggregator that continuously gets streaming telemetry, right? So
Right.
it may be that the aggregator needs to do that job then and do the trigger edge detection as to collect and dump its reports.
Okay. I've got a different alternative that I have in mind, and we can discuss that. But I note your comment. Other comments before I plow on? All right.
Yeah,
So,
I have a
yeah,
question.
John,
So,
go ahead.
yeah, what's the end state of this? Are we going to add another requirement to what is needed, or so we stated right? We have what we have, and you said there's a new use case. So, is the end state of this discussion to add another requirement into the document we're writing?
That is my purpose in this
Okay,
discussion.
okay, all right. Then that wasn't clear. So, fine.
Thank you. Thank you for bringing clarity. All right. So here's an example for an issue that my company holds near and dear in making Ethernet NICs. So if you look just some basics for those of you who don't do networking, you've got an Ethernet link that connects two pieces of equipment. In this example, I'm thinking most Ethernet links. I mean, if I ignore, yeah, even in the scale up and scale out networks that we're talking about for AI, Ethernet links typically connect host servers to Ethernet switches. And if you look at the individual link at the highest level, you can think of it as having two states, link up and link down, and that should be self-explanatory. So there's this phenomenon that happens, unfortunately, and we call it a link flap. And so the idea is that the link is up and data is flowing back and forth. Everybody's happy, and then for some a relatively short amount of time, and that's that that's up to the observer, I guess. For some amount of time, the link goes down, and then the link comes back up, and so we call that a link flap. And when a link flap occurs, if you're trying to diagnose or fix something, or let's just say that the first thing to note here is that there's potentially five different hardware elements that are involved in this link flap. There's the NIC at the host server. Most of the time, or very commonly, there's a pluggable transceiver, like an optical transceiver module, plugged into that NIC. There's a cable uh, towards the switch. There's a transceiver module option potentially plugged into the switch port, and then there's the switch. And problems in any of those five elements or the connections, like like where the cable plugs into the module, or where the module plugs into the NIC, or where a module plugs into a port, those things could be kind of flaky. And sometimes network operators, when they see link flaps, the first thing they'll do is they'll go around and wiggle the cables. Um, even in development, not even data center networks, but when I'm having trouble maintaining a link up, and I'm using remote equipment, the first thing my support guy does on the other end, where the equipment is he goes around and he wiggles the links, wiggles the cables. And sometimes that works, sometimes it doesn't. Um, and these things happen in practice. The question is, how often do they happen, and how long do they occur for? So I made the statement here: when a data center operators experience a significant number of link flaps, and significant is in the eye of the beholder, they're going to do certain things. They're going to want to diagnose the cause. Like, for instance, which piece of equipment is contributing to the problem? They're going to replace what they consider is the errant hardware elements. Depending on how good their diagnosis was, they may be replacing elements that were good, that weren't the root cause. And then as the numbers climb, they'll complain to their suppliers. Hey, you're giving me garbage. And I can tell you that they complain to the supplier, whichever supplier has the highest number of link flaps, they'll complain to that one first, to beat them down and get them in line with everybody else. So I see it as a real occurrence that data network operators care about, and the suppliers care about this process by which these kinds of problems are diagnosed and characterized. There's also I've talked to a lot of people, and they think that a lot of these link flaps, they could be predicted ahead of time. They could, if you properly are observing the physical layer metrics, like received signal to noise ratio, RX, TX, the transmit temperature laser, you could be looking at this stuff proactively. Well, how do you know which stuff to look at proactively, and how often to look at proactively? Well, you'll learn over time. And so over time, if we have this ability to send additional information, especially pre and post event, the network operator could get a better intuition of what physical layer observations can be associated with an imminent link flap. And so they can learn over time, and they can actually refine the metrics that they look at on a regular basis, or set event thresholds for predicting when those things go out of line. So the idea is that over time, the operators get better intuition, they do better diagnosis, and this mechanism could really help their intuition and help them diagnose problems. Any comments on this page before I go on? Yep.
Yeah.
Panos?
I always have comments. So I was thinking to inject a page in your thoughts. I was thinking of the physical limitations of telemetry, and that's like has a good segue of what you're trying to describe here. So there is a few physical limitations. So you don't have infinite bandwidth to transfer all the amount of information you have. You don't have infinite storage to store all the metrics in their full granularity that you could have been collecting, right?
Right.
Time moves forward, and the propagation of events is not instantaneous, right? You may
Right.
have even like buffering delays, or even you have a link down, so the events will arrive after the link is restored, right?
Mhm.
So also you cannot go back in time and collect something you failed to collect before. So you need to have something that can like store them and report them on demand. And this goes back, and the other limitation is you cannot just implement that on any level of the network that you wish, right? There is a limitation. Yes, like uh, I know that yours and your competitors' nick cards are very smart nowadays, but let's assume they were dumb and they can only report their link status as being up or down. And then you
Mhm.
have another like a few meters that you can collect from the nick card, plus a few meters that you can collect from a sibling equipment as like the Redfish, the BMC, or the host itself, right? So at the point, so you start the sequence of link going down, which may come up or may not come up. Like by the limitation of time that you cannot tell the future, you don't know if and when the link will come up again. If it stays down, it's a different condition. If it comes
Yep.
back again, you have one pulse. And then you need to go back and say, is it one pulse? Is it a series of pre-existing pulses that have already been observed in the past? Or is it a series of one pulse that will repeat itself in the next 5 seconds, right?
Right.
So this is a thing, and you start assembling that event on the fly. Once you have assembled it, like now that you are on the 15th second and you have had 3 or 4 flaps, which constitute your condition of like a flapping event, now you may not want to go back 15 seconds and say, okay, what is my temperatures or my laser power readings for the past 15 or 20 seconds? And I need to get them in better granularity that I would be doing them when the link is idle, or the link is like stable up, right?
Yep.
So this is a problem of aggregation, and I would say that under the limitation that you cannot have dumped all that information in its full granularity in a huge database, because everything has a cost, you could have local buffers in aggregation nodes that collect that, compile all that composite information, because this cannot come, or let's say it cannot be implemented in a NIC itself. Let's think of like these ancient dummy NICs that we used to have like 20 years ago. And then in the aggregation node, you need to have this protocol that can implement that logic we just described. What do you think?
So a lot of what you've said, um, I I think, and you're going to see a slide to this
Yeah.
against this. A lot of what you said, I think, could be done at the leaf node, but you do make a good case uh, for the reasons that we keep discussing, that these things become more and more complex, and we want to push this as much as we can down to the leaf node where there's more power. But you make a great case for dumb managed sensors, and maybe the BMC, server isn't powerful enough to do this kind of thing. Um, which begs the question, should we make this some of this movable to an aggregation node?
Yes.
How,
So
how,
let's say we wanted to aggregate, or to give another example. So you have a NIC flapping, and you have a NIC flapping on the other NIC of the other host, which goes to the same switch port,
oh
right?
yeah, yeah,
So physically you cannot do this aggregation on the leaf, which is your single NIC port, but you need to aggregate over 2 ports, right? Let's just inject this limitation as to have this discussion, like let's assume that this cannot be done on the leaf, and what is the next stage that we can do it.
yeah, yeah. That's a good point. And I was conscious of a network operator wanting to try to correlate link flaps across multiple machines, but I just didn't get there in the maturity of the development of this set of slides to work through that. But that is an excellent point. All right, other comments? I'll continue on. All right, so what I've got here, and you'll notice I try to copy whenever I can. You'll notice there's some similarity between that slide, which was done at OCB, and there's a certain geometric similarity here. So what I've got here is I said I just first stab. Okay, we have this packet, and what this packet could contain is a bunch of information that we that comes in layers or stages. So we have this. We certainly want some basic cause information. What was the event that happened? What time did we determine that we had a trigger? But the kinds of things you'd want in any kind of event report, we could put in the basic cause information section. And then there's a section more or extended. I could have called it extended cause information, but I just couldn't fit it in the space I had. So I called it more cause information. But this is more detailed information specific to the particular cause. In my example, it was a link flap. And then optionally, some pre-event metrics, and then and optionally some post-event metrics. And do we try to let's say that we have like five or six other metrics that we're trying to figure out. Is there a link, some kind of causality that we can show, or maybe just um, I'm forgetting the term, but the coexistence, the coincidence of other metrics doing wonky things with this link flap. And so we take some measurements before, we take measurements after, and if we're doing that for multiple different metrics, I mean, in my toy example, I have, the receive signal to noise ratio and the transmit laser power. And so do we put those, do we lump those together in some kind of format? All the pre-event metrics are here and all the post metrics are there. Or do we say, well, this is the pre-event and the post-event metrics for laser power. And then following that, we could have the pre-event and the post-event metrics for RX signal to noise ratio. So a lot of thinking needs to be done to refine how we can put this information in a flexible, extensible, and yet efficient format for processing.
I'm just thinking of like an oscilloscope frame
Yep.
that you can have a time series of measurements. So their timestamp, they like perhaps relative to start or whatnot. And then you can have an extra field adjacent to you have like the measurements of that value over time at fixed or irregular intervals, and then you have another measurement of something that constitutes the event that also has a timestamp, and that timestamp may be within the range of the first events. Like the first events are from time 0 to time 10, and then you say my triggering event is some other measurement that happened at time 5, for example. So you're constructing like a set of time series. Let's say you put that on a frame, that you put a set of time series, each one time stamped, and the second or the last one in the set is the one that constitutes the event, the triggering condition, and it's also conveys the time that this happened. It may be 5, it may be in the middle, it may be 10, it may be 0, it may be 1, right? So you're flexible to that. You're flexible to that. You don't put additional flags to say this is post or pre. You're just like presenting the various measurements on the same time scale.
Okay, so let me just translate that. If I'm looking at a logic analyzer display, the top I give all the data for the top line first, followed by the data for the second line, followed by the third line, yada yada yada.
Yep.
Okay.
And it could be your fourth line is your triggering event, right? Arbitrarily.
Yeah, or I'm thinking the triggering event, the triggering event typically isn't a line. It's just I mean, it's not a horizontal line, it's a
an edge.
vertical line.
No, I'm saying it's an edge, right? Like there is an edge that you can observe on the fourth channel, and that edge constitutes your trigger. Or it could be a sequence that, like on your fourth channel, you have received a byte sequence like OX5, and that byte sequence, when it completes, it constitutes your trigger, right? Whatever, like it is a vertical line because it's an edge, but still you can represent it as a time series representation with, let's say, only two samples. You have sample at time 0 to 5, and then sample from 5 onwards that change the state.
So that's not as efficient, but what's your motivation? Is it that it could be rendered for viewing much easier?
My motivation is to be generic as to not try to encode all the other measurements in their final format. Right. The other
Right.
measurements sitting on a buffer, and at the point that you have a triggering event, you're just sampling the buffer and you send all this thing out.
Right. The thing I'm struggling with though is it seems to me inefficient to send a time series for an edge. Um,
You don't need to have like infinite samples in there. You just have like a few samples. They may be on a different time series that the other events.
oh,
Like
on a
not
different time
synchronous.
basis?
Yes, different time basis. Yes.
Ah, okay. I hadn't thought about that.
Yep.
My assumption was that the spacing of sampling for pre and post event metrics were uniform. But you're saying let's be totally
Yep.
general and just
Yep.
give times samples that and the times that were sampled.
Yep.
Yeah, we'll have to have some more thought about that.
I'm just saying that this could be a solution, right? To
Yeah,
be generic
yeah.
enough. Yeah.
Okay. And I guess really yeah, and so we'd have to consider the difficulty in constructing the packet, the difficulty in parsing it, and the difficulty or the efficiency of transporting it. But yeah, that's a different way than I was thinking originally. All right. Other comments on this? All right. So this slide is mostly to step back and try to think about the high view of how why this thing needs to be different than what we've defined so far. So I make the claim the configuration of enhanced error reporting, it's very different than the parameters needed for streams because, for one thing, the individual metrics for pre-event and post-event time series likely differs from the streams already established from the data center. Like, for instance, you may have a stream, you may be like one main stream that's got, 30 parameters coming at a certain rate. And then but for when these things happen, when a link flap happens, I don't need or want 30 things. I want like these 5 things, which may or may not be included in the 30 things that I was regularly looking at. So we need to have the flexibility to look at different metrics than any given stream parameters that we have set up. And then those parameters are likely to differ over time because you might start with one of the initial drilling down into these time series might be, well, give me 6 parameters, and I don't have infinite buffering, so here's the time parameters. um and then as you get more and more mature in your understanding and your intuition, you may want to narrow that, or you may want to widen it, or you may want to get more intense sampling. But in my mind, there's this just like when you sit down with a logic analyzer at a bench, there's a continuous evolution of knowledge that demands you configure the logic analyzer in different ways to get to the next step of understanding.
I just thought of like a very difficult example
Yeah.
to throw here. So suppose you have your network card, it's a development card, and it has a bug. So you see a link down event and you have some measurements, something, but you then realize that if you had collected the bytes received, you would have seen them stagnating 10 seconds before the event. For some reason, like the link was appearing to be up, but you had 0 bytes received for the past 10 seconds. So this is a thing that you could have sampled in a regular, like this is contradicting to what you said, or arguing, let's say, what you said about the metrics you don't want, right? So
Right.
had you collected all 30 metrics that this card would have thought, you would have noticed post the event that you have a blank a stall period in receiving bytes, right? So
Yeah, you're
that
right.
means that's a bug in the card. Something happens, and although the ledger was up, you were not receiving anything. Were not decoding any bytes. So this is what I was saying earlier, that one of the physical limitation is going back in time and recovering information. On the other
Hmm.
hand, you need to balance that with the fact that you cannot be collecting everything all the time, right?
Yep.
You don't have like infinite storage and infinite bandwidth to transfer all the measurements. So having something that constitutes a buffer and you can go back as an event and check other things would be beneficial. Or
Yep.
it could be something that is collected on the aggregation node as not to strain the network from the aggregation onwards and upstream. So it goes from the leaf node to the aggregation node, like perhaps like the leaf node falls off the network when this happens. So you have some data in the aggregation node, and you can play with that and build some logic that will collect that as soon as something happens, and then you can send them for analysis.
Yeah, the thing is though, I really think that this is going to be unmanageable and it's not going to scale up.
Yep.
Um, but
I
I hear
agree.
what you're saying. You're saying leverage the memory in the aggregation node is basically what you're
Yep.
saying.
Yep.
Okay. All right.
And
Yeah,
that's
we'll
what
have
the aggregation node is for, right? So you're not sending everything up, but you're also not dropping it on the floor until something happens, because at the time that something happens, you need that information. You cannot go back and collect it again in
yeah.
retrospect. Yeah.
Yeah. All right. So that would be contrary to what I said on the second bullet of this, the second major bullet. It should bypass aggregation modes. We'll have to. This is a great stimulating thought
Mhm.
that we'll have to spend some more time on. Um, I think I know the answer. So yeah, when I initially put this together, I thought we should bypass the aggregation node, but Hannes, you're giving me some reasons why we shouldn't, some motivations to include them. Um, should enhanced event reporting pass through filtering nodes? I think you're going to say yes, because there's probably some information there that for the same reasons that we want to sanitize it for external parties, we'd want to sanitize it here. Do you think that answer is yes?
Yeah, I think it's like a matter of configuration, whether you want that to be filtered, you want some events to pass through or some to be dropped there.
Okay. Um, the last thing that this slide says is that we should leverage the ideas we have about leaf mode aggregation to pack more useful characterization of pre-event and post-event metric observations on the information that actually traverses the network, and for instance, goes up to an aggregation node, among other things, perhaps. And so this is the slide that I cribbed from OCP. So, and we've talked about this before. You've got hardware on the leaf node, or an implementation on the leaf node, that is capable of collecting samples at a much higher rate than would be reported. And so I think we could leverage some of these same ideas and say that some of these pre-event and post-event metrics that we're reporting are equivalent to the red dashed lines, and they're still, in between the dashed lines, there's sampling going on. But what we're including at the red lines are things that could help the network operator characterize in some degree what was happening between the observation reports. Next steps: need to create a SysML model, and you know, I uh, I should put something here. More discussion about how, if and how to leverage aggregation nodes. All right. Uh, Need to create an initial SysML model that we can look at and argue about. That would include advertise, and some of these things are analogous to what we've already done for the regular bulk reporting. The advertisement of capabilities from the leaf node, establishment of sessions for enhanced event reporting, and then some abstract format of the data to be conveyed when a specified event occurs. And we've talked about some of that today, and this has been a good discussion. I'm looking for additional use cases too. So I need to put out some advertisements to some of the other people that are signed up for this group but aren't showing up yet at meetings to ask for other use cases uh, for how to, I'll post the slides and ask for additional use cases long beyond long uh, above and beyond link flaps. Um, and I don't know if you have any right now that you'd like to share. We've got a little bit of time left before the top of the hour.
Yes, I'm scratching my head to remember like good examples.
Hmm.
Um, I may definitely have some that not everything can be disclosed here. Like not everything we see can be disclosed, but we can have like some classic common examples that everybody has seen. Um, like we have been talking, and the fault management group has been talking about super records, like enhanced debugging, and that falls into collecting more information and posting it when something happens. I wanted to say that like the aggregation nodes should be a complementary facility to what a leaf node can do, right? There
Hmm.
is some limitation because the firmware on the leaf node or the software, or the capabilities of the leaf node may be limited. Let's not assume that it's a generic purpose computer that can do anything. It can load any software at any time. So the aggregation node will jump in and fill in that functionality when it's not available on the leaf node. Also, the the scaling of aggregation of combining events from multiple sources and multiple nodes. This is what the aggregator can do, and the leaf nodes cannot do themselves. But the point is how to combine that and create this event stream, not stream, this event notifications with a standard protocol, right?
Right, right. Yeah. I see the aggregation pretty much mirroring what you said. I think that the aggregation nodes could be considered optional um, for doing some of the time series work on an individual node. The aggregation node could be optional because the thing it would add or bring to the table is perhaps more memory resources and resilience if the single node crashes.
Yeah.
I can see that the aggregation nodes would be absolutely required if we're trying to correlate the same kind of event across multiple machines.
Yeah.
All right. All right. Panos, you and I are the only ones left.
Yeah.
This has been a good discussion. I need to do a better job at bringing in some other folks. And I'm going to really try to think about that over the next couple of weeks, with the break as to how to get people, hopefully near the beginning of 2026 to provide a more active participation.
Okay. Yeah, I can already talk about myself that we have had so many open issues at work. So I have not been able to provide you with the documents and all these things we have discussed in past meetings. So yeah, we need to get together and like make a case. The other thing being for our own employers, we need to prove that all this work is significant and can be used by them immediately so that they can pour more resources into it, right?
Absolutely. I
Yeah.
struggle with that
Yeah.
a lot.
Yeah. You know what I mean?
All right.
But the other thing is the collaboration, to say that okay, yes, if we identify as the cloud operators that we need, let's say, the simplest thing like a circular buffer implemented in the telemetry of a Broadcom NIC, to name your employer, is something that we can prove the usefulness of that feature and talk and get that spec'd and implemented if possible. So that would be a win for your product to have, right?
Right. Right. Okay.
Okay.
Any other thoughts?
No, we're okay. Are we going to have a meeting in 2 weeks'
No,
time? What's the
no, we're
day?
not going to
Yes.
have a meeting. What
We're
is it?
not.
Christmas Day or the day
Yeah.
after
Yeah.
Christmas?
Yes. It
No,
would be the
we're not going to have a
27th,
meeting the day after
27th. Yeah. Yeah.
Christmas.
Yeah. So I think we should schedule. We could have a new series to do on the plus 3 weeks from now and do on the or would it be, no? It would still be
Yeah.
festive
Let's do
season.
4 weeks.
Yes. Yes. Yeah.
Let's do 4 weeks. I think
So
it's let me pull up my calendar. Um, I'm going to be out of town, but I can participate um on the 9th of January. I'm still I imagine a lot of people are still going to be on PTO. I don't know. Well, I don't know about you, but I will be on PTO the 2nd of
good.
January. So I'm
Good.
proposing that we restart 4 weeks from today, which would be January the 9th.
Nice. Okay, that's a good date because January the 2nd would be still, very close to the festive season. Okay, so Merry Christmas to you then.
Merry
Enjoy your
Christmas
time.
to you.
Yeah.
And let's try to make some
Yeah.
progress
Okay.
before I mean I've got a week and a half before I go on
Yeah.
PTO. So let's try to make some progress before the Christmas break and hopefully come out with guns roaring on January the 9th.
Good.
All right. Talk to you
See.
later. Bye.
Talk to you.